In this video, we are going to cover some circle basics. We'll start in the top left area of the notes, where we will talk about radius, diameter, perimeter, and area. We're going to make the assumption that in the picture, point Y is at the exact center of the circle. We're also going to say that points W, X, and Z lie on the circle. A chord is formed when you have 2 points that are on a circle that are connected to each other with a line segment. So chord WX, which also happens to run through point Y, is a diameter of the circle with length D. Line segment YZ is a radius of the circle with length R. A radius is a line segment that has one endpoint at the center of the circle and another endpoint on the circle. The perimeter of a circle can be calculated by using the equation perimeter equals 2 times pi times the radius, or pi times the diameter, since a diameter is 2 times the radius. The area of a circle is given by the equation area equals pi r squared. Using this information and the circle on the left, let's do a couple of sample problems. If D equals 6, what is the area of the circle? So D equals 6. The radius is half the diameter, so that means R is equal to 3. Now we can use the area formula. So area equals pi r squared, or pi times 3 squared, or 9 pi square units. If the length of segment WY is 5, what is the perimeter of the circle? WY is another radius of the circle because it has endpoints at the center of the circle and a point on the circle. So if the radius is equal to 5, we can use that to calculate the perimeter. So the perimeter is equal to 2 times pi times the radius, or 2 times pi times 5, or 10 pi. Moving on to the bottom left section of these notes, we're now going to talk about central angles, arc measures, arc lengths, and sector areas. So again, we're going to assume that point A is at the exact center of the circle. This means that angle A is a central angle of the circle. Since segments AB and AC are both radii of the circle, that is going to form that central angle. If we connect points B and point C to create line segment BC, we will actually reveal a hidden isosceles triangle, triangle ABC, where angle B and angle C have to be equivalent to each other. Anytime you have a central angle, in this case angle A, that is going to be equal to the measure of the arc that it creates. So angle A is equal to the measure of arc BC. The length of arc BC is equal to angle A over 360 times 2 pi r. In other words, all we're doing is we are taking the proportion of angle A to the total number of degrees in a circle, and then using that and multiplying it by the perimeter of the circle to get the length of just that segment. The area of the sector enclosed by angle A and arc BC is angle A over 360 times pi r squared. Let's use that circle on the bottom left to answer a couple of questions. If angle B is 50 degrees, what is the measure of arc BC? So angle B is 50 degrees. That means that angle C also has to be 50 degrees because we have an isosceles triangle. Since we have both of those angles, we should also be able to figure out that angle A is then 80 degrees. That's because the 3 angles of a triangle have to sum to equal 180 degrees. Knowing that the central angle, or angle A, is 80 degrees, we can calculate the measure of arc BC because it is equal to the central angle. So the measure of arc BC is also equal to 80 degrees. If BC has a length of the square root of 2 and the length of AB is equal to 1, what is the length of arc BC and the area of the sector formed by angle A and arc BC? So let's actually draw some numbers on the circle. So BC has a length of root 2, and we are given the length of AB is 1. We should also know that the length of AC is 1, since they are both radii. What else can we determine from this? Well, we should be able to determine that this is a right triangle. Because we have two side lengths of 1 and 1 of the square root of 2, that actually fits with the definition of a 45-45-90 triangle. So angle A has to be 90 degrees. Now that we know the central angle is 90 degrees, we should be able to calculate the length of arc BC and the area of the sector. So the length of BC is equal to angle A, which is 90 over 360, times 2 pi r, or 2 pi times 1, since the radius is 1. In other words, we have 1/4 times 2 pi. That gives us 1/2 pi. Now let's figure out the area. So the area is going to be equal to angle A, which is 90 over 360, times pi r squared, or 1 squared, or 1. So that's going to give us 1/4 pi square units.